All right, so today in algebra, we're going to extend our knowledge of the quadratic formula and use something called the discriminant, which is contained inside the quadratic formula, to help us kind of guess ahead of time how many solutions or x-intercepts, which is where y equals 0, a quadratic equation will contain. So we're just going to use it to predict how many solutions or x-intercepts a quadratic will have. And you'll see how that kind of applies as we look at the next few slides. So before we start, the first thing you need to know is what on earth is the discriminant? And in front of you, you should see the quadratic formula. You should know that after yesterday's lesson. You should have that memorized or be in the process of memorizing it. But the discriminant, as I said, is contained inside the quadratic formula. And the discriminant is actually this piece right here underneath the square root. So this piece right here, this b squared minus 4 times a times c, this is called the discriminant. So from this point forward, if I'm talking about the discriminant, I'm talking about the part underneath the square root in the quadratic formula. And what's really cool is we can use the value of that discriminant to help us to actually predict how many solutions a quadratic equation will have. So before we move forward with predicting how many solutions a parabola or a quadratic equation will have using the discriminant, let's talk about how many x-intercepts a parabola can actually have. So here I'm going to draw a set of axes, and first I know that a quadratic equation could have two solutions. We've seen that with the quadratic formula and with factoring, and our two solutions where y is equal to 0 is actually that x-intercept, and we know that there could potentially be two solutions. However, we also know that there's a situation where a parabola only touches the x-intercept or the x-axis one time. So there could also be a situation where we only have one x-intercept or one solution. And then there is also a situation, believe it or not, where a parabola could actually contain no x-intercepts, where it doesn't come all the way down, it doesn't touch that x-intercept as all, and as a result there are no solutions or x-intercepts. So every time we're solving a quadratic equation, we're going to get two solutions, one solution, or no solution. And moving forward, we're going to use this discriminant right here to help us to actually predict how many solutions we will have before we actually solve an equation that contains a quadratic. So what we're going to do in the next few slides is we're going to do 3 examples, and each one of these examples will have a different value for the discriminant, and then we'll, as a result, have a different number of solutions. So here, in this first problem here, we can use the quadratic formula. It's written equal to 0, so I know that a is equal to 1, b is equal to 6, and c is equal to 9. So let's use the quadratic formula. We have x is equal to negative b plus or minus the square root of 6 squared, or b squared, minus 4 times a times c, all divided by 2 times a, which is 1. So here, if we evaluate this part underneath the square root, if we kind of focus in on here, this discriminant, we will have 6 squared minus 4 times 1 times 9. Well, I know that 6 squared is 36, so 36 minus, well, 4 times 1 is 4, 4 times 9 is 36, so I have 36 minus 36, which is 0. So really, if I rewrite this here, I have x equals a negative 6 plus or minus the square root of 0, all divided by 2. And if I keep going with the quadratic formula, so I'm going to shrink this and move it up a little bit, I know that I would split this into 2 components. So here I have x is equal to negative 6 plus the square root of 0, which is 0, divided by 2, and x is equal to negative 6 minus the square root of 0, which is 0, divided by 2. And this becomes x equals negative 3, or x equals negative 3. So let's make a little note down here that when the discriminant, so that's our discriminant, equals 0, our number of solutions, really, these are the same thing, so we only have 1. So here our discriminant was 0, and as a result, our number of solutions was 1. So we're going to compare this to the next few slides after we're done. So notice here that when the discriminant was 0, we had one solution with our quadratic formula. All right, so question number 2. This one we have an a value equal to 1, a b value equal to 5, and a c value equal to 6. So if I use the quadratic formula to solve this, I have negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So from here, I'm now going to evaluate my discriminant piece underneath the square root. So here I have 5 squared minus 4 times 1 times 6. So this is 25 minus, well, 4 times 1 is 4, times 6 is 24. 25 minus 24 is 1. So I know that x is equal to negative 5 plus or minus the square root of positive 1, all divided by 2. And then I know here that the square root of 1 is equal to 1. So then as I split this into two problems, I have x is equal to negative 5 plus 1, because the square root of 1 is 1, divided by 2, or x is equal to negative 5 minus 1 divided by 2. So negative 5 plus 1, that's negative 4, divided by 2, x is equal to negative 2, or negative 5 minus 1 more, this piece is equal to negative 6. Remember, this piece was equal to negative 4. Negative 6 divided by 2, x is equal to negative 3. So here I have two values. And something to note here is that when our discriminant was something that was positive, our number of solutions was equal to 2. So our discriminant here was a positive 1. So if we have a positive number, our number of solutions is 2 compared to the previous slide when we had a discriminant that was 0 and our numbers of solutions was 1. All right, and finally the last one here. So we're going to use the quadratic formula one more time. A is equal to 2, B is equal to 3, and C is equal to 5. So I have x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So here, if I look at this piece underneath the square root, I have 3 squared minus 4 times 2 times 5. So here, 3 squared is 9 minus, well, 4 times 2, that's 8. 8 times 5 is 40. 9 minus 40 is equal to a negative 31. So here, if I rewrite this, x is equal to negative 3 plus or minus the square root of negative 31, all divided by 4. And then my next step would be to split this, but if we look at this for just a second, the square root of negative 31, if you plug it into your calculator, will give you an error. And that's because you can't take the square root of a negative. And as a result, in this particular situation, we know that we can't take the square root of a negative number. That's just something we're not capable of doing at this stage in our math. So we know that we can't move forward with this because this is going to produce an error. And how can you add negative 3 with an error? So at this point, because we have that negative number underneath the square root, we state that there is no solution. So something to note here is that our discriminant had a negative value and our number of solutions was 0. So we're going to, on the next page, compare the past 3 slides that we've actually looked at. So in the past 3 slides, we did the quadratic formula 3 times, and what we noticed is that what was underneath this square root, or this discriminant piece, actually helps us to determine how many solutions we are going to have. And if the discriminant was positive, what we noticed was we had 2 different solutions that would make that equation containing x true. So we would find 2 solutions, 2 possibilities for x if this discriminant value right here is a positive underneath the square root. When the discriminant was 0, what we noticed is that we only had one solution. If we use the quadratic formula, we would maybe find two solutions, but they happen to be the same thing. So there's only one unique solution to our quadratic equation when that discriminant value right here, this value underneath the square root, is equal to 0. And then when that discriminant was negative, what we noticed was that we had 0 solutions, or as I wrote on that screen, we had no solution at all that would make that true. So when this value underneath the square root in the quadratic formula is negative, when it's negative, we know that there's not going to be any solutions. There's going to be a negative underneath the square root, and that's going to halt our process. There will be no solution for that particular quadratic equation. So from here, what you should be able to do is, prior to actually calculating the solutions, you should actually be able to determine how many unique solutions you will be finding. And that's what we're going to do on the next two slides. Look at the equation that we've been given and use our knowledge of the discriminant to help us predict two solutions, one solution, or no solutions. So the two problems here say use your knowledge of the discriminant to determine how many solutions, or x-intercepts, and remember, x-intercepts is when y is equal to 0, so that's where we would be substituting 0 in for y there, each equation below will have. So we're not going to solve the quadratic equation all the way through. All we're going to do is focus in on the discriminant, that b squared minus 4 times a times c. So if we do this here, let's say, okay, a is equal to 3 here, b is equal to 4, and c is also equal to 3. So let's use the discriminant to help us. And I'm going to write out the quadratic equation. You can just focus on the b squared minus 4ac, but I want you to see that connection between how what's underneath the square root is determining how many solutions we will have. So I have my quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Then what I'm going to do is I'm going to focus right in here on the discriminant, this piece that's underneath the square root. So I have 4 squared minus 4 times 3 times 3. So this is 16 minus, well, 4 times 3 is 12. 12 times 3 is 36. So 16 minus 36. This is telling me that I have a negative 20 underneath my square root. And I know that when that discriminant, or that value underneath the square root, is negative, that I'm going to have no solution. So when my discriminant is negative, I will have no solutions to that quadratic equation. Now if I move on and look at number 2, this one I'm looking for x-intercepts, or where y is equal to 0. So here I'm going to use the quadratic formula as well, because really we're saying, okay, pretend y is 0. Now find what the x-intercepts are. So a is equal to 2. B is equal to 8, and C is also equal to 8. So here we're also going to use the quadratic formula to help us. X is equal to negative B plus or minus the square root of B squared minus 4 times A times C, all divided by 2A. And then remember that discriminant, that piece underneath the square root, is what can help us determine how many solutions we have. So I have 8 squared minus 4 times 2 times 8. Well, I know 8 squared is 64. 4 times 2 is 8, and 8 times 8 is 64. So I have 64 minus 64, or 0. And I know that when my discriminant, or my value underneath the square root, is 0, that I'm going to have one solution. Because if I use that quadratic equation, I'm going to get the same value twice. So on the next slide, what I'd like you to do is try the next two on your own. See if you can do those next two on your own, determine no solutions, one solution, or two solutions, and then watch the end of the video and see if you answered correctly. All right, so to walk you through, this one's saying use your knowledge of the discriminant to determine how many solutions or x-intercepts each equation below will have. So this first one in number 3, we know we're looking for x-intercepts, so we're looking for when y is equal to 0. So here we're going to use the quadratic formula. A is equal to 3, B is equal to 2, and C is equal to negative 12. And then from here, I'm going to use the quadratic formula, so x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So remember, with the discriminant is underneath the square root, so that's what I'm going to focus on to determine the number of, or how many solutions or x-intercepts we have. So I have 2 squared minus 4 times 3 times a negative 12. Now, to make sure I don't make any mistakes with my negative, I'm going to use add op here. So 2 squared plus a negative 4 times 3 times a negative 12. So here I know 2 squared is 4. I also know negative 4 times 3 is a negative 12. And then I know negative 12 times a negative 12 is actually 144. So when I add those together, I get an answer of 148, and that's what's underneath my square root under the discriminant. So I know here, because that is positive, I'm going to have 2 solutions. And then if I look here at number 4, this one I'm trying to find how many solutions. I know that my a value equals negative 1. My b value, which is the coefficient of x, is 0 because I see 0 x's in this problem. And then my c value is equal to negative 12. So here I'm going to use the quadratic formula again. X is equal to negative, b is 0, plus or minus the square root of 0 squared minus 4 times a, which is negative 1, times c, which is negative 12, all divided by 2 times a, which is negative 1. And then to determine the number of solutions, I'm going to focus in just on the discriminant. So I have 0 squared minus 4 times negative 1 times negative 12. Excuse me, that should be a 12, so I'm going to erase that and fix that quick. And then from here, I'm going to use add op to, again, prevent myself from making a mistake. So plus negative 4 times negative 1 times negative 12. So this becomes 0, because 0 squared is just 0. Negative 4 times a negative 1 is a positive 4. Positive 4 times a negative 12 is negative 48. So I have 0 plus a negative 48, which is negative 48. And because I have a negative number as my discriminant underneath this square root, because it is negative, I know that I'm going to have no solutions or 0 solutions to that equation.